Right now, at this very moment, the universe is expanding. Not just moving, not just changing, but expanding in every direction at once. Galaxies are drifting farther apart, space itself is stretching, and the universe is becoming larger with every passing second. And somehow, holding this cosmic chaos together is something we cannot see, cannot touch, and barely understand. It's called dark matter. Together, the expansion of the universe and dark matter shape everything we observe, from the motion of galaxies to the fate of the cosmos itself. Today, we're diving into one of the greatest mysteries science has ever faced: how the universe expands, what's driving it, and the invisible substance that controls it all. For most of human history, we believed the universe was static and unchanging. The stars were fixed, the heavens were permanent, the universe simply existed as it always had. That idea shattered in the early 20th century. Astronomers began noticing something strange when they observed distant galaxies. The light coming from them was shifted toward the red end of the spectrum, a phenomenon known as redshift. The farther away a galaxy was, the more its light was redshifted. This wasn't random. It meant those galaxies were moving away from us. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. He found a direct relationship between a galaxy's distance and how fast it was moving away. The farther a galaxy was, the faster it was receding. The universe wasn't standing still. It was expanding. But here's the part that often confuses people. The expansion of the universe doesn't mean galaxies are flying through space like debris from an explosion. Instead, space itself is expanding. The distance between galaxies increases because the fabric of space is stretching. A helpful analogy is dots drawn on a balloon. As the balloon inflates, every dot moves away from every other dot. None of the dots are the center. Expansion happens everywhere at once. This means there is no center of the universe, no edge, no single starting point you could travel to. Everywhere is expanding. If the universe is expanding, then logically, it must have been smaller in the past. When scientists ran the cosmic clock backward, they reached a stunning conclusion. Everything we see today was once packed into an incredibly hot, dense state. This moment is known as the Big Bang. Around 13.8 billion years ago, space itself began expanding. Not from a point in space, but as space. Time, energy, matter, and the laws of physics all emerged together. As the universe expanded and cooled, particles formed, then atoms, then clouds of gas. Eventually, gravity pulled matter together to form stars and galaxies. Expansion and gravity have been locked in a cosmic tug-of-war ever since. At first, scientists assumed gravity would slow the expansion over time. After all, gravity pulls things together. With enough mass in the universe, expansion should gradually decelerate. But in the late 1990s, astronomers made a shocking discovery. The expansion of the universe is not slowing down, it's speeding up. Distant supernova observations revealed that galaxies are accelerating away from each other. Something unknown was overpowering gravity on the largest scales imaginable. This mysterious force became known as dark energy, a separate but related mystery to dark matter. Together, dark matter and dark energy dominate the universe, while everything we can see makes up only a tiny fraction of reality. So where does dark matter come in? When astronomers began studying how galaxies rotate, they noticed something that made no sense. Stars near the edges of galaxies were moving far too fast. Based on visible matter alone, those stars should have flown off into space. The gravity from stars and gas simply wasn't enough to hold galaxies together. Yet galaxies remained stable. The only explanation was that there was far more mass present than we could see. This invisible mass was named dark matter. Dark matter does not emit light, it does not absorb light, it does not reflect light. That's why it's called dark. We can't see it directly, but we can observe its effects through gravity. Dark matter acts like a cosmic skeleton. It forms massive halos around galaxies and galaxy clusters, providing the gravitational glue that holds them together. Without dark matter, galaxies as we know them would not exist. In fact, dark matter played a crucial role in the formation of the universe itself. After the Big Bang, matter was spread almost evenly throughout space. Tiny fluctuations in density existed, but normal matter alone wasn't enough to collapse quickly into galaxies. Dark matter, however, doesn't interact with light or radiation. That allowed it to clump together earlier and faster, forming gravitational wells that pulled ordinary matter along with it. Stars and galaxies formed inside these invisible structures. In a very real sense, dark matter built the universe's foundation. Today, scientists estimate that dark matter makes up about 27% of the universe. Dark energy makes up about 68%. Everything else, stars, planets, gas, dust, and life itself, accounts for less than 5%. Most of reality is invisible. And we still don't know what dark matter actually is. Many experiments are currently searching for dark matter particles. Some are buried deep underground to shield them from cosmic radiation. Others use massive detectors in space. Some scientists even hope to create dark matter in particle accelerators. So far, it has remained elusive, but its influence is undeniable. We see it bending light through gravitational lensing, shaping galaxy clusters, and guiding the large-scale structure of the universe like an invisible hand. Now let's connect dark matter back to the expansion of the universe. While dark matter pulls matter together through gravity, dark energy pushes space apart. These two forces work in opposite directions on cosmic scales. In regions like galaxies and galaxy clusters, gravity, boosted by dark matter, dominates. These structures remain bound despite expansion. But on the largest scales, dark energy wins. As space expands, dark energy becomes more influential, accelerating the separation between galaxy clusters and shaping the universe's long-term future. What does that future look like? If dark energy continues behaving the way it does now, the universe will keep expanding faster and faster. Distant galaxies will eventually disappear beyond our observable horizon, their light stretched beyond detectability. Billions of years from now, only the local group of galaxies, including the Milky Way and Andromeda, will remain visible. Beyond that, darkness. Stars will burn out. Galaxies will fade. The universe will grow colder, emptier, and more isolated. This scenario is known as the heat death of the universe. Yet even now, scientists aren't certain this is the final answer. Dark energy could change over time. Dark matter may have properties we don't yet understand. New physics could completely rewrite our predictions. Every discovery opens new questions. The expansion of the universe tells us that reality is not static. It is dynamic, evolving, and far stranger than we once imagined. Dark matter tells us that most of existence is hidden from view, detectable only through its gravitational whisper. Together, they reveal a universe that is still full of mystery, a cosmos where what we see is only the surface of something much deeper. The night sky may look calm and eternal, but behind it lies a universe in motion. Space is stretching. Galaxies are drifting. Invisible matter is shaping everything. And somehow, on a small planet orbiting an average star, we've learned to measure it, question it, and wonder about it. And our understanding is still catching up. The universe is expanding. The night sky may look calm and eternal, but behind it lies a universe in motion. Space is stretching. Galaxies are drifting. Invisible matter is shaping everything. And somehow, on a small planet orbiting an average star, we've learned to measure it, question it, and wonder about it. The universe is expanding, and our understanding is still catching up. Thank you for watching.